All right. Are you able to hear me clearly, Mitesh? Great, great. So yes, when we last time left, meaning day before yesterday, I was trying to show you how to do the sorting. All right. I was trying to show you how to do the sorting. And let me, okay, great. So the recording is on, and all right. So sorting, as we have already discussed even during our Hadoop sessions, it is one of the most basic and most important function, most important translation of data or transition of data. Okay. Sorting essentially means ordering the data by some criteria. For vectors, the function called sort does the trick, while for data frame etc, we should use a function called order. All right, I will show you. So let us say that we have some data. Okay, so as you can see that let's attach our empty cars data set. You remember what does it mean by attach empty cars? Okay, so attaching empty cars means that MPG will become one vector available, correct? Each of these columns will become available as local data set. All right. Next is that, so cars equal, let's just take the row names. And what did we do to get the row names from our data frame? Yeah. So row names, right? When we say row names, empty cars, we get all the names. Let's say we want to sort these names. So that's pretty simple. We can just say sort. All right. So this way we can simply get the we can simply sort the vector. So sorting vector is pretty straightforward, but sorting a data set requires basically finding out what will be the new order of things, and then switching the rows accordingly. Correct? So when we say views empty cars, so you can see this here. So basically, it essentially, if you want to sort this table by a particular column, say MPG, so it will involve first sort this data of MPG, find out which one has become the new index of the data, and then accordingly switch the rows. All right, and that is done using a function called order. So what does order return? Order essentially return the order of new order of things. So you can see that A is rat, bat, cat, and if I order A, it will essentially tell us that these elements will be the new order of things. It basically returns in new indexes. Okay, so bat will become the first element, cat will become the second element. That's what it's saying. The second element will come in the beginning, then will come third element, then will come the first element. Okay, that's how order works. Make sense to you, Mitesh? So that's how order works. Now, as you can see that we can do the same thing for other elements also. Let's imagine for time being that we have another element called cat, all right? And let's say we want to say that in case session has already started. Okay, so Sasikant has also joined, and all right. So in the meantime, I'll also turn on the projector. All right. So here you can see that if we want to sort by some other order, okay. So let's say this. All we want to say is first try to sort by A, and if all the value, if there are conflict at A, we sort it by second column B. All right. So we say order A comma B. Now it says that 2 will come first, then 3, then 4. Okay, and then first. Or let's say it was -2. Now if you say this, you say 2, 4, 3, 1. Make sense, Mitesh? Awesome. Awesome. So we were talking about ordering of the elements. And is correct only. No signal. So with this we are trying to move to, okay. We are trying to display it on the projector. All right. So is this clear to you, Shashi? So we are trying to order elements of A using A and B. We are telling that this is how your element should be compared. Okay. So order basically generates the new permutation of the new indexes of the elements. Indexes start from 1, and you can use multiple columns for ordering. Okay. And if you want to order by decreasing order, you basically can do things like I think this should generally work.
Minus order?
Yeah, I think that will be better. No, not minus order. So I have actually.
No, order, comma ascending equal to.
Oh, descending equals to true. Ascending equals. I'll show you. This is decreasing equals to false. We have said decreasing. If we have to say here, we have to say decreasing equals false. Okay. So yeah, A is this. No, decreasing equals to true. A, B. This is how you do, right? Order A and B. Right? So you can quickly see the help here. Yeah, this is how you write. So decreasing equals argument length differs. This is only correct only.
Just a minute.
All right. I think this sounded correct. Let me just see what is it that I'm making a mistake. This is hi. I was planning to, start even without anybody today.
Recording.
No, order is correct. Okay, order is correct. And if you have ordering in place, you can say order. You can see that ordering is correct only. Maybe oh, I am typing it wrong way. I should say decrease. Now make sense to you? Decreasing equals false. Now if I say decreasing true, then it will be 1, 3, 4. Okay? All right. Is this clear now? Okay. Now the question would be, a difficult question would be if you have two vectors. Okay. If you have two vectors A and B, you want to sort one with increasing and other with decreasing. So what will you do? Okay.
Order of order.
Yeah.
Order of vector A. Order of vector.
Order of vector A and order.
Order of vector.
Okay. Or maybe put a negative sign. This one. That's
order inside order.
So like this.
No.
Yeah. This might work, but the problem with this approach is in case you put negative on the string, it says no. All right?
No, what I meant is order instead of B, order of B.
So A and B, we are given two arrays. So we want to find out the final order of elements. When we sort, what will be the final order? For that, you can use order. Okay? So order A means 2, 3, 4, 1. All right?
2, 3, 4, 1. Correct.
Sridhar, is that clear to you? So order basically finds out what will be the final order of things after sorting. So rat, bat, cat, cat. Okay? So cat will come first, then will again cat come, and then will, bat, cat, cat, rat, right? Bat's index is 2, cat's index is 3, another cat's index is 4, and then rat's index is 1. Yes, yes. So it basically tells us that this is, if you order your element like this, then this is your final order. Yeah. Correct?
Comma order B. B is what?
B is another array. 1, 1, 1, 2. So we can order two things. If you want to say that, try to order it by first. If there is a conflict, then use the B. Okay. It's like saying order by one column, second column, third column, fourth column. Make sense? So sorting on multiple columns is done using order. Now, question is that how do you fit it in? So this gives us the final order, right? Now, can we utilize sort command to sort? Can we utilize this to sort our data frame? Mitesh, are you with me? So, yeah, can you help me out in that?
So where is the data frame?
Yes, not logical vector, but normal indexing. So let's say we have empty cars. Okay, you can see the empty cars data set. Now in this, what I want to do is I want to order it by MPG column. Okay, so as we said, MPG we have attached. So MPG is locally available. When we say order MPG, it is going to give us the indexes, correct? Now, if we say empty cars and square brackets and we say order MPG and okay, what did we do actually? So now it will give us, let's just give us one here. We can say give us only the elements from 1 to 3. Okay, so yeah. So now you can see that the data is sorted. And how is that data sorted? Can anybody help me out? So we first said MPG, correct? That gave us an index. Now we told empty cars data frame that give us the rows in this order. Give us the rows in this order. All right. This is clear, right? In the similar way, so basically, we using the order command, the usual order command, we can sort anything we want. Shashika, Sridhar? Car names, okay. Yeah. So how would you do that? Can anybody help me in that? So Sridhar is saying, can we order using car names?
Names of empty cars.
So what we will do is we'll say cars. Sorry, we'll say order. Order on basis of what? Row names.
Row names of empty cars.
Empty cars. Correct. Correct. Thank you, Mitesh. I see that. What all did we do? Let's just break it down. I think breaking it down will be a better idea. So let's say, what does it row? This will give us what? All the row names of empty cars. Order will give us their new order if they are sorted. Okay? And empty cars will give us all those rows which we are asking and the same order in which we are asking. Okay? What do you say? If so let's say we have to give decreasing order, Sashikant and Mitesh and Sridhar. So if you have to give it in decreasing order, what will we do? Here, comma, decreasing equals. You see that? Sounds good? Yeah. If you give call names, so their respective columns will, I'll show you. So if you have call names of empty cars, so you have these columns. If you try to order them, what will happen? This will get sorted. So if you want to order things in empty cars, if you want to order the columns, okay? If you want to order the columns, then we will use this. Now you'll see that. Okay. Let me put in a view, then it'll look little better. You can see AM has come before, carb has come before. So the columns are now sorted. Okay. So sorting the columns in case of a SQL was almost impossible. Do you remember that?
Sorry.
Sorting the columns was almost impossible. What we have done here, see, AM has come before, carb has come before. So the column names are sorted.
Okay.
Okay. How would you sort column names in SQL?
Column name?
Yeah. If there is a table which has 1,000 columns, and you want the columns in the order.
We put that column names in that order, right?
You'll have to type it, right? You have to type all the 1,000 columns.
Oh, 1,000 columns in this.
Yeah.
That is how it depends on how. No, each table, will have a metadata table, which will have column name.
Yeah.
So
but that will be different for all the databases, right? That's not part of standard SQL.
Yeah, but for sure, metadata is a standard. Some DB has to maintain metadata.
Metadata is there. So,
yeah.
So basically, SQL does not expect you to sort columns. There's an exception.
Correct.
That doesn't come into DDL, data definition language. Sorry, DML, but it comes under DDL, right? So they'll vary from one database. So here, that is the benefit of having this kind of a system where you are able to manipulate data in more flexible way. You see the benefit, Mitesh?
But here, joining two data frames and manipulating is tricky, right?
Yeah. So joining, no, I'll show you. Okay. So, all right. So everybody comfortable with sorting? How can I increase the size of this guy? All right. I think this will be better. All right. This is good. So this basically, I was trying to show that is how you can sort the data based on those variables. Okay. All right. Now, these MPG and CYL are available as vectors. Why? Because we have done attach. Otherwise, if we had not done attach, this MPG variable, as you see here, will not be available. Okay. Now, next is that merging one-to-one inner join. So whenever we have to merge two data sets together, we can use merge commands. Okay. Merge command is exactly like the way it is there in SQL. So I think Mitesh is saying something. Correct. Yeah. So Mitesh is answering to the question if we did not attach the data set. All right. Now, if you have to merge the data set, you have to deal with whenever you have to deal with multiple data sets, it's obvious that you'll have to merge it. So we don't need to. So one very easy way of pasting two data sets together is by basically pasting it by doing rbind or column bind.
Yeah.
That is the easiest thing. Or creating a new vector using two vectors, creating a new data frame by adding two more. But that doesn't suffice almost all the time. Okay. So let's have a look at it. So we have two existing database, baseline and events, having the keys in the same order. All right. Now we can simply either say cbind. We have already done this kind of thing, column bind, where columns of first one and second one will attach side by side. All right. But for cbind, you have to have equal number of rows, in both the data sets. Otherwise, it will either give an error or it will try to repeat. All right. So as you can see here that baseline has how many? Baseline says, give me row number 1 to 5 and column number 1 to 6. Now events has row number, all the 5 rows and column number 7 to 11, same data set. Now if we join these by using the cbind, if we join these two data sets using cbind, it's nothing but bringing up the same empty cast data set from 1 to 6 and 7 to 11. Effectively, after cbind, all data will have 5 rows and 11 columns. All right, but it doesn't solve our lot of problems. Now that's where the command called merge comes into play. The syntax of merge is merge x comma y by dot x equals variable name, by dot y equals a column name. So here what we are saying is that we have got x and y, and the column on which we will be merging these two data sets will be defined by by. For x, this first data set, we pick up this particular column. For second data set, which is we pick up the second data set column, and then we try to do the cross multiplication. Okay, we do the cross multiplication for each value of x, each value of this column name in x. We try to find out corresponding value in y, and then we join it. Okay. If we say all dot x equals to all, or things like that, then it will basically do a cross multiplication. Okay. And okay, so the other parts of I'll show you a few more things. We can also say all equals to false means strictly equal join. If we say in here, after placing the comma, if we say all equals to false, it means if there are records in x for which there is no value found in y, that means that those records do not go in the output. If there are some records in y for which the value is not found in x, that means the output will not contain those records. All right, and therefore when you merge it, it will not give you the correct results. It will have only those elements which are found in both. Okay, and the criteria of matching is based on this column. All right, now in some cases what you want is, I want my x variable even if that does not exist in the y. I want it in that place. If it is not found in the y, just place NA. That's what I want. Okay, in those cases you can say that all dot x equals all. Okay, that means all values of x will come. And if you say all dot y equals to all, that means for y, even if some values of y are not found in x, still that will go in the result. Should we try it out? What? I'll just show you. I'll just show you something. Okay. Suffix is the output column names. When you join them, there will be new columns generated. So what should be the suffixes? By default, it put the suffixes as the column names, the data set names, for new tables. Yeah. So does merge works on just data frame alone? Yeah. Jagdish, let me try to explain with an example. Then it will make sense. All right. All right. Now here we have a big table. Let me just try to write it down first. All right. So is my screen visible to you? Good. Now let's say there is a data set X in which there is Ryan, Giri, and okay, I'll say one. I'll do a little better job. I'll say one Ryan, two Sandeep. Okay. We have Y table which says one Saha, two Giri. All right. And let's put 3 here. Okay. Let's call it here. Let's call it 3, and let's call it Shravani. Here, let's put it 4, and okay, and it, all right. So there are these. A has 1, 2, 3 ID, and B has okay. I think a better thing would be to do say X underscore 1. I think that will give you a better clear picture.
We write employee names and department.
X underscore. All right. And so that way you can see, we can say here Y underscore 1, Y underscore 2, and Y underscore 3. Correct? Yeah, echo will not be there now because can you turn your I'll mute everybody. Now there'll not be echo. Jagdish, do you hear the echo? All right. Now if I say merge X comma Y, okay, and I say by dot X equals to okay, and let's call it ID and name and ID and F name. Okay. So now if I say by dot X equals to ID and by dot Y equals ID. Okay. Then what will happen is it will give us what will be the result?
X1, Y1, 1 X1, Y1, 1 X2, Y2.
Correct. So we are saying we are saying here all equals false. Then what do we get?
So there 3, here 4. Okay. All equal to false. Only 2 rows will be there.
Only 1 and 2 will come in the output. Correct? Because the ID of this is found here. ID of this is found here. Perfect?
Yeah.
Now if I say things like this, we say all Okay. Do you want me to do?
X data.
All right. What will be the best way to create this? Let me first try to create these variables.
A equal to.
So I can say A equals to or
Name equal to.
just put everywhere. Makes sense, right?
Testing. So the expression.
Okay. So see the trick is, these are the things, right? I want to first do is replace this along with the new line, put a comma. Okay. If you do that, why it's not working? Oh, see that? Right. So you can do things, cool things like this, and this is one. So I'm trying to do stupid things, but never mind. And I'm just trying to create.
Last one didn't get quotes.
Okay, let me just try. Yeah, you're right. Won't get the codes because there was no new line here. Okay, and in the similar way, I can. So yeah. This way you can actually utilize regular expressions in your normal routine. Okay. So now we can say x equals to
We'll say names. It will add a column name.
Yes, yes, we will say
Name equal to.
x equals to data frame. Okay, and we say id equals to c1 to 3. All right, make sense? Now it should work. Data dot frame we have to say. So now you can see that it just added some column name. We have to put one column name for this. Let's put name equals to. Okay, cool. So this is good for us. And in a similar manner, we could also say things like here, and we can simply say y, and y. It's not visible. I think it's some ghost or something. All right. Now you can. I'm just trying to create the data set on the fly, a more simpler data set, so that now it's saying incorrect dimensions. Is there incorrect dimension? We can say, yeah, we have to say put round bracket. Right? So we have got x and we have got y. Is it clear? Now when we say merge x comma y, okay. So x comma y, it tries to match on all columns. Y dot x equals to id, and so x is 1 to 3. What happened? Oh, my mistake. Now it's correct. Thank you, Mitesh. So 1 to, oh, okay. Oh, what's happening? Why is this still?
Yeah. Error.
So it's happening in this way. One, two, and three. No, this is correct. Oh, I don't understand what happened earlier.
There is already one C variable, I believe. Let's see C, type C.
That's correct. Oh, we were putting this way. Ideally, we should have put it how we should have put it like this. Is it? Yeah, we are correct. We can have just.
Or we can remove C also.
This pattern. All right. So yeah, the mistake was that there is already a variable called C which has some values, and if you try to do that, it will give the error. Okay. So we have generated our x and y. If we merge x and y just like that, it tries to match all the columns, and then you have to say by dot x equals. You have to say by dot x equals id, and by dot y equals id. All right, makes sense to you? Again, x is this, y is this. Now you can see that when we merge x and y based on id, you get only 1 and 2 from the first one and 1 and 2 from the second one. And you see the new columns that are generated, their names are this way. Jagdish, is that clear to you now? This is for merging the data sets. All right. Next is that if we have to merge these two, and we want no matter what. So there was a column called 3 from x. It did not come in the output. Okay. In those cases, what we can say is by default all equals to is false, which means if the id is not found in the output, it says all x. Okay, so we can say true. And now you can see when we say no matter what, whether the value of x is found in second data set or not, give me the results from x. So value of all of the values of x should be there in the output. In case nothing is found in the second one, put NA in that. In the same manner, if we say all dot y equals to true, so you can see NA. That means for this value of x, there was nothing found in y. For this value of y, nothing was found in x. Okay. This is the same concept as outer joins in SQL, left outer and right outer. Okay, so do I need to explain the physical significance of these things? What are the benefits do you get out of this? Jagdish, Mitesh? So the physical significance is, imagine this. You were having X as the employee and Y as the salary. And you would want to display the salary paid for all the months. Okay, salary paid for all the months to the employee. So you have one is employee and other is month-wise salary for all the employee. Now imagine that for a particular month, there is and in the output, what you want is if the salary was not paid for the user, you want to display it as 0 rather than nothing. You want to display it as 0 rather than nothing. In all those those circumstances, you will want all the values of X, all the values of employees, irrespective of whether salary was paid to them or not. If the salary was not paid, just mark it as 0 or NA. Okay. In those cases, you will always want the values of X in the output because you want to display the name of this employee even if the salary is zero. Okay. So that is the significance of the inner joins. Sorry, outer joins, left outer join or right outer join. Basically, it is there are many other examples where you would want the result from one side even if there is nothing found on the other side. Okay, did it make sense to you, Jagdish, Mitesh, Sridhar? Hmm? So yeah, now you can see the difference between, so you know X and Y, right? When you have strictly inner join, then if the value of X, which was 3, was not found in Y, so 3 and 4 did not come. If you say, give me results X's value, whether it's found or not, then you say all dot X equals to false. Okay, that means sorry, all dot X equals to true. That means you will get the result of X even if the value, that 3 ID, is not found in second one. Make sense? Same case is with, if we say all dot Y dot true, then Y's value will come in the output, whether that particular ID, 4 ID, was not found in X. Doubtful?
So if we compare this to SQL, then all that Y is equal to is right outer.
Right out.
All that X is left outer.
Perfect. Perfect. That's how it is.
Yeah.
All right. So what time do we have to break today?
30 normal break or
No, afternoon.
we go at 1 o'clock?
1 o'clock. So Jagdish and Mitesh, 1 o'clock would be better. So,
So only half day, right? Today?
huh?
Only half day.
That's what I was told.
Yeah, yeah. We leave at 1 o'clock.
If you want, I can continue for the day, actually.
No, we have a TV event.
Okay.
Then can we take a short 10-minute break?
Today? Now? Jagdish and Mitesh, maybe you also take a break for 10 minutes? Have a coffee?
Thank you.
I'm starting to record and we'll start the session. All right. Good, good. So this test was from you, right? Yeah, one Sasi is, one Sandeep G is Skylab, another is myself, and third one is Sashi. All right. So before the break, we were talking about. All right. Before the break, we were talking about how to merge the two data sets. We also talked about the inner joins. All right. So I think it's not required any longer. Also, the way we were joining on one column, we could also join on multiple columns. Okay. Earlier, we were joining on ID column. We can also join on multiple columns in that sense that when both the values of first data set will match both the values in the second data set, only then the records will come together. So essentially you can have the composite key rather than a single key. Make sense? So you can, instead of providing by.x, we could also say, we could also provide by dot x and then column names from one and another. And correspondingly, those columns will be matched. All right. Make sense to you? So should we try doing something on this? Empty cars is there, or let's say x is there and y is there. Now let's just try to change the a little bit of definition. We put 1 and we put 1 here, and rest are same. Okay. So essentially what am I saying is, now x is this, y is this. You can see id is 1, 2, 3, name is 1, x underscore 2, and so on. Correct? Now what do I want to do is, I want to say merge x comma y by dot x equals id and name. All right. And I say by dot y equals id and name. Okay. We have to put C because we want vector. Now you can see that only one record has matched from both the sides. All right. Why? Because we are trying to match two columns from both sides. Or if we want to match all columns from both the sides, we could simply remove all the arguments and it will do the same for us. It will try to find the corresponding column on both the tables, all of them, and will try to merge them together. All right. So that's how most of the merging works. So you can think of it as newer way of saying SQL. All right. Now, similar to group by and ungroup by, there is you haven't used flatten, right? So flatten and group by are inverse of each other. Similar to that, we have shape and reshape. Okay. So basically, reshape does the same thing. Whenever we have to change, okay, whenever we have to change the data, we have to transform the shape of the data, then we use reshape. Now, what does this command do? It basically, so in this, if you can see here, okay, okay, so here it says that reshape my df, okay, reshape my df, okay, reshape my df, and using these as the columns, okay, and direction is wide. What does it do? It says that it basically, what do you say? It, for those values, it's like group by, okay? It's like group by. Based on those two columns, it will group the data, and then whatever, if there are values duplicate for a single row, it adds them into columns. Okay, I'll show you this. So here, so which slide is this? 125. Okay, so let's just define something called df3. Okay, we have df3. You can see df3. Okay, so df3 is, it has got a class, school, and then timing. Okay, so the data is first sorted by school, then class. So you can see that for 1-9, okay, it's not actually sorted. How do we sort it quickly? Somebody help me.
Sort by.
What? Order, and I say df3, okay, dollar school, comma, df3 dollar class. All right. So let me copy paste again. Yeah, I'll give you this. So yeah, df3 is, I've just created some df3 with some random score. All right. Now you can sort it, right? The way we discussed earlier, using this command. Now this is the sorted df3. Okay. Although it's not required, I've just done it for representation purposes. So we say that these are the values. For these two values, we want to, flatten the data. We want to flatten the data, as in these two records we want to create as multiple columns. Okay. So we can simply reshape the data using commands like this. We could say reshape this particular data frame, and okay, these are the ID variables, and direction is wide. Now you can have a look at what does wide mean. So what did it do? Okay. So school is 1 and class is 9, time and 1. So for time dot 1, for score dot 1, the value is this. For score dot 2, the value is this. Okay, you can see that this has become first column and this has become second column. Okay, and the name of the column has become the time, the third one. Makes sense to you? So we basically converted it into, and now in the similar spirit, if we remove the class from here, what will happen? Or let me just say, okay. So here there is not much of a difference. Okay. Is this example clear to you? So this is clear, right? Whenever we are saying, it's like group by, we are saying group by these two columns and we get this data. Instead of applying a aggregation function, the data has been pushed from rows into columns. All right. So there were two values, right? For 1 and 9, those two values have become the columns.
We specified only school and class.
Yeah. So where did the time column go? Time column has become, just a second, and so yeah, dfx this 1, 2, 1, 2, 3. Okay.
Can you put a class of df2?
Class of df2. You mean to say this? So it's again a data frame only. Okay.
Now, how does it know that it should be time has to be factor variable?
Yeah. So just a second. Let me also understand where did my. So this is my DF3. Okay. DF3, and I say 1, and I say 1, 2, 3, 4. This is my score. Okay, so whenever we do this kind of thing, what it does is it basically takes these two values. Let's say I say class, and then I say score. So it says that data frame, okay. Okay, so now you can see that. So when we grouped based on class and score, so class and score remained intact, while school has moved to the another column. Okay, so for here you can see that for class 9 and 10, and then for a particular score, okay, the value of school has moved to another column, but since there are no duplicates, it almost remains empty. So school.1 means for school and 1 as the time dimension, and school becomes the column. School.1 means for time 1 school this. Okay, so basically that matrix, that instead of saying one is school separate columns, they have separate rows, they have become separate columns. Okay, so this value is for time equals to 1. Okay, and here is the only question here is that okay, so you can see the value equals to 3. Okay, so this is the value of school dot 1 means time equals to 1. The value of school is 1, 1, 1, and then time equals to 2. Value of school is 3 here for 0.758, 0.758. Okay, so you can see that. Okay, so basically the school column has become 2 columns. School columns have become 2 columns instead of 1. 1 column for the composition of school and time, time equal to 1, a school and time equal to 2. Okay, how should I describe it? So now you can see, Mitesh, where did the time column go? Okay.
But how does it know that it has to be widen by time? Here it is create widen as a
Correct.
1 and school at 2, right?
Correct.
Why not
So,
it is 1 dot 2?
Yes, that is something we can have a look at reshapes behavior.
I think it will take a factor.
Okay. So on what basis it is trying to the time variable. So by default, if there is a column called time, that's considered as time. If you have another, if our df3, whatever df3 was here, okay, whatever df3 was here, let's say df3 was this, okay, and time, instead of time we had time 1, okay, and now let's see what happens. So df3 is there, but instead of time 1 we have time this. Now if we try to do this, it will give us error saying undefined column selected, okay. Reason being, there is no time column selected, so we have to say things like this, okay. Put it in double quotes because it's a string. You can see that. So by default, it looks for time column to reshape. Otherwise, you can specify some other column as time. Okay, make sense? So for those values where there were duplicate rows, we have taken those duplicate rows, put them as column. Okay, and basically considered picked up a column called time, took it to the horizontal dimension, and that's how we have done it. All right. So this is how you generally reshape. Now under reshaping, there are many other functions we will talk about. So it's the same diagram. So Jagdish and Skylab, is this clear to you, Mitesh? Cool. All right. In the similar way, the other reshaping is group by, proper group by aggregation, with aggregation, and we can do that using by command. There is some command called by, in which, let's say there is a data frame called air quality. Yeah, go ahead, Amitesh.
I think it is muted all.
Yeah, everybody's muted. Correct.
It's the opposite word of aggregate.
It's not aggregated essentially. It is basically flat, moved. Columns became rows. It's aggregation only, but the aggregation in another way, that values have become just the columns which you can later on aggregate. All right. But yes. Now let's say there is a database table called air quality. I think it should be there. Air quality. Yeah. So in this data set, you have got, let me close these, otherwise it will start crashing. All right. So cool. Now, if you can see the air quality, it has got ozone label, and then you have got solar.r, and then wind, temperature, month, and date. Now, if you do head, you will get just first few record rather than having the screen brightness. We call it screen brightness when you so many records scroll through your screen. Okay, now you can see that these are my records. Now I want to do is I want to by my ozone level I want to aggregate it. Okay, I want to convert it into we want to compute the mean of month. Okay, let's just do that. And so I know this may not be very well visible. Zoom out, view, zoom in, view, zoom in. Ouch. It's actually hard. This is the only way to zoom. Can't zoom it. What happened now? Okay, so we were trying to do aggregation. All right, so we were talking about by air quality something, and yeah, this is far more clear. So you can see what we are trying to do here. So we are saying by air quality ozone list is this, okay, month, and we need to compute the mean. So month 5, okay, this is other way around actually. It's basically, okay, so it's taking the air quality ozone, it's the single vector taking, and then it's saying that this is my list of variables on which we need to group the data. And afterward, we are basically saying compute the mean. Okay, compute the mean for these variables. Okay, so basically it takes, what does it mean? This one, it means nothing but a list containing only months, and this essentially contains ozone layer. So we have got two vectors. So on first, the second one will be what on which it will be grouping happen. Okay, grouping will happen on the second column, and the new column which will give is the month one. It will generate the for each value of month, okay, so we'll go through these, find out for these months whatever is the average till here, okay, and then it will compute the mean of all the ozone layer. Okay, so I've muted everyone, so now it should not be a problem. All right, so you can see that what I've done is I have told, basically I gave two vectors to buy. One was on the basis of which the grouping has to happen, and what data need to be grouped, and what function needs to be applied on that. So here I'm applying mean function on top of this. Make sense? So this is how we are computing the that this is how we are computing the group by. You can see that for fifth month we have found out all the values from second table, and for those particular values we have passed those values from ozone to mean. Make sense? No? Now what if we have to do this over multiple multiple values, multiple columns. Okay. Say we have air quality, and in this air quality, we want to say that for each month, and each day, that will not be a great idea. Is there a year or something?
Can you show the statement again?
Your question is which statement you want to see?
Group by month.
Group by month. Yeah.
That's it.
This one. Oh. Can see that? So all we have to do here is, in case of list, we can just put another variable on which we want to do the grouping. Okay, we can say x equals to some other things. All right, and then it will group based on those two fields. All right. So this is the grouping is clear, Sashi?
Yeah.
Sridhar, Mitesh, Jagdish, and Skylab. Okay. Jagdish, eco problem is there still? All right. So, where did it go? All right. So the variable to be analyzed was air quality. A list of variables defining the subset, and there is a function. There is one more variable called na.rm. Na.rm as in remove all the elements where na occurs. Okay. If you remove that, the elements which are going to give na, mean null, will be removed, and then the function applied is mentioned.
Monthly and daily also is there.
Where is that? Okay. So I think you can just put list day equals something, and then. All right. If you want an easier example, I think this is far more easier example here. So this is my data frame. Let's call it D. So this is my data frame. So you can see D. For value 5, we have got 1 and 2. Okay. And what do we want is we want to compute by A dollar capital A. Okay. We are grouping it by, we are grouping A dollar capital A by A dollar B, which means fifth one, which means 1 and 2, the mean will be, okay. Isn't this correct? Oh, I did not assign it to A. All right. Now you can see that for month equals, okay, so we could also, whatever we want to say is, let's say my m, okay. Now you can see that for m equals 4, which is the value of b, the average of 3 and 4 will be computed and then saved. So in the same way as this one, okay, good. So this is clear, right? The group by clause. All right. And in this group by, not only mean, but any function you want to call, you can make call. If you remember, yesterday we understood how to call a function in R, right? Yesterday we discussed that, and you can also how to create your own function. So you can create your own function called mean.n.sd and equal to function, and then you define the function called mean equals to mean of the values, whatever you pass, and comma standard deviation. So it will return two values instead of a one value, and then you can utilize those. Then you can utilize this in execution. Right? Let me. Do you want to try it out?
Yeah.
So we are defining a function called this. Let's just create a text file. We are defining a function called this. Okay, and we are putting this, and let me close this sketch note, and then in this we are essentially returning these. Sorry. So here, okay, so we say return. Yeah, now it's working. So if you try to execute this function without any with some argument, say 1, 2, 5. So this is correct only, right? Yesterday the problem was this. Now it is correct. Yeah, this is actually earlier also it was correct, but yeah. You can see that? No? So I created a function of my own which does mean and standard deviation. Okay. So although we'll discuss mean and standard deviation today, you can assume that we can call our own function here. Okay.
We can use our index values in function.
Yeah.
So for a mean and deviation,
Yeah.
you have to give the index values. Right?
No. You just have to give vector to mean. We are just giving vector to mean. Basically, compute the mean of those. And also, we can also do something like this. And we did not need all of this actually. This is sufficient. Okay. Now mean and this. Oh. Will it work now? Yeah, we have to put that round bracket inevitably. Yeah? So here 5 plus 2 plus 1 is 8. Because I changed the definition to sum, that is why you're getting this. Okay. Now, once you have defined such kind of a function, you can apply that function on your data. So you could say things like this. Okay. For each value, we are able to compute mean and standard deviation. Right now it's sum. Okay. That is another form of reshaping the data or aggregating. Okay. So we are able to run aggregation on top of existing data. Those are out of box functions. Now, if we say two, which means we want to, if you have a data set, if you have a data frame like air quality, and what you want to do is column wise feed my data to mean and standard deviation. So pick up each column and pick up all the values and feed it to mean and standard deviation, and whatever values are computing, report that. So that is how it is working. If you say one here instead of column wise, if you say one here, it will basically do it row wise. Okay. Go to first row, take all the values and try to sum it up. Make sense? That's another aggregation. So that's without group wise. We are trying to aggregate the data column wise. You can do the same aggregation using your own function. Like round.msd we are defining here, and we are saying please group my data by a combination of month and day. Here, group my air quality data. Pick up only these three columns and group it by these two columns, and then round the data during aggregation. For each month and day, find out the round and MSD. Okay, so round and MSD using. Now there is another thing hidden here. First is you can you created earlier, you created your own function called mean and standard deviation. Here we are creating one more function, round.msd, which is mean and standard deviation. We just gave it a new name, and there is a big subset. There is a big subset. We are again applying this function inside it and calling it. Okay. So that way, we can recursively call the function and do the aggregation. Make sense? No? So here, whatever table comes along, whatever data set comes along after aggregation. After aggregation, if you see, you get multiple columns, multiple values. So for each of month, each of day, you will get basically multiple values. Okay. And here, instead of saying only one particular value, we are here. Earlier, if you remember, instead of saying air quality, column 1, column 3, we were just returning one vector. Right? Here it's a data frame. Now to aggregate data frame, your logic should take data frame and then aggregate the data frame. Now how it's happening? We are having round on MSD, which is taking the data frame. Okay, it can take a data frame, and out of the data frame, first it's applying on the set of it. First is calling apply. Apply basically will call column wise. It will call on this data set called subset. It is going to call mean and SD on each column of that data set. And inside this function, inside mean and standard deviation, what we are doing actually, we are basically calling the mean and standard deviation, which take two values. Okay, makes sense? So I've got some questions. Yeah. All right. So here the idea is, okay, let me take this table and then try to explain to you. So let's go to next one. Okay. So what we are doing is air quality, one column. Okay. Air quality here, comma, one column three. Good. This is how it looks like. All right. How do you? So let's say we have got this data. So what is going to happen is when we say for this data run my aggregation. For this data run my aggregation. Based on what? What is my criteria for aggregation? For each month and day. For each month and day, it is going to find out. It needs to be. I need a bigger screen capture. Why it's not there? Now, air quality dot month. Air quality dot month is what? Air quality dollar month. Am I typing something wrong? M is capital. Okay. So for these months, each of this month, and for day. Okay. So for each of these days, whatever comes out, imagine that for each day and month, there are these 10 records came out. These 10 records came out for each day and month. All right. So what will happen is, first, each column will be picked up. Okay. So when we say when we say group by, and imagine that after group by, this is the data set which has come out for each month. Each month and day, this is the data set. Imagine. All right. Now on this, we are saying apply round.msd. Okay. For each of this, we are applying round.msd on the whole database table. Now what is going to happen is, here in this function, it is going to say apply on this data set column wise, two equal column wise, this is 2, that means column wise, and for each column mean and SD are going to be called. For each of these column, this and this, okay, wherever we want, this is going to call the round.msd. Okay, for all three of these. Okay. Now, and what does round.msd do? Nothing but it calls underneath whatever was there function, it calls that. Okay. So apply did the magic of iterating over column wise. Okay. And then okay. So what did apply do? You remember apply when we apply? Apply, if you say 2, then it will apply on column wise. Okay. If you say 1, then it will apply row wise. Okay. Make sense? So we basically it applied this particular function on each column of the data set. Right? Let's try to do that if this works out. Okay. So it says round.msd is not found. Let's first define round.msd. Okay. Round.msd is there. See, this is our round.msd function. Okay. So to round.msd, if we pass two vectors here, my x, I'm creating just some example here, and y equals to c of 10 to 13. Data.frame. This is correct only, right? No. Yeah. So now you can see that this data.frame, whatever we created, this one, and we can say my data frame is this, my df is this, and I'm passing round.msd, my df function. So it's for each column, it is computing the mean, which is for the first one, 1, 2, 3, the mean is 2. For 11, 12, 13, the mean is 13. In the first case, the standard deviation is, we have changed the standard deviation definition where it was, we have converted it into sum. So just computing the sum, 2 plus 3 plus 1 is 6, 13 plus 12 plus 13 is 36. Okay. So it has computed these values for the full data frame. Make sense to you now? So now everybody is clear about what does round.msd do. Round.msd basically computes means and standard deviation of each column in a data frame. Now, if we apply the same function, yeah, any questions? All right, if we apply the same functions in by, then we can simply, now I think now this sentence will make sense to you. We are saying take a data frame, okay, group it by certain columns. After grouping itself, another data frame or data set will be there. On that data set, please apply this. Okay. Now everybody is clear on this? Now you can see that each subset of the data set, it has applied those functions. Mitesh, Skylab, Jagdish, is it clear to you now?
Can you go to round.msd function once?
I think Peter is also there. Peter, can you hear me clearly? Yeah. So we basically modified it for time being like this. We changed it. If you see this, mean and SD, we just said this. Okay. Instead of saying SD just for the heck of it, we changed our function from sum to SD. Mitesh?
Now on the slide we use one of the, can you open the slide? Yeah, that's one. That's the MSD.
Yeah. Tell me now. So there are two functions. One is one that works on a data frame, other that works on individual columns. Okay. Now first function was mean and SD. Okay. That was supposed to work on a single vector. All right. Hmm? Make sense? No. All right. Mitesh, should we go ahead? Jagdish, Sridhar, and Skylab. Awesome. So moving ahead. Now this is something which we have already discussed, which is grep find only. So grep, what does it do is it takes one regular expression, it takes a vector, and then it basically returns another vector containing all those elements which where this particular regular expression is found. Okay, not, I'm avoiding the word here. I'm avoiding the word called match. Okay, I am saying that regular expression is found. Matching means end-to-end matching. So did I disconnect? Everything all right? Perfect. Perfect. So what we are trying to do here is we are trying to say graph. Okay. So I think you should give it a try. Mitesh, you want to give it a try? Skylab, is it working for you? If it's not working for you, I can take a quick look at your screen. I'll just copy paste the code here for you. This one. So let's say you have txt equals this, txt equals this. So we created txt. Then we have grep, and we are saying, okay, so it returns a vector of the indices where it has been found. Okay. Make sense? You can see that, let's say we say this and we say type a class of C, and you will have, oh, it's an integer. How come? It should be a vector, right? Yeah, it's a vector. All right, make sense, Skylab and Jagdish? Awesome. Now, okay. Next is the, I think this is what we have, sort of discussed already. So, okay. Similarly, we can say substitute this wherever this regular expression is found with something else. Okay. Now you can see that here what we are trying to say is replace. Okay. Can anybody tell me what does the regular expression mean? This particular regular expression? Yeah. So it says sub, then bracket. This one you see, sub. So what will it do?
either A or B between group for any group of A or B,
Hmm.
it substitutes with
Yeah. So it will be A underscore B underscore then others. Okay.
A underscore A underscore B underscore.
So let's try it out. So we have this. Okay. So with yeah. So it will basically say one underscore two times, right? Whatever has been matched. Correct. Correct. Okay. Now let's see what's the difference between G.
So
Okay.
it
So
goes further.
yes.
That one does the first match.
Yes. So the first one basically does not replace globally while G sub does the job. So mostly you will be using G sub instead of the normal sub. Okay. First sub basically stops after doing few operations. After doing the first operation.
Can you go to prompt again?
Yeah.
Oh, end. Okay.
Make sense? All right. Now, okay. So normal regular expression basically returns the position of the first match, while G regular expression does it globally, the same thing as the previous example. Like you can have a look at what we are trying to do. We say, first let's define the text. This is our text now. Text, you can see it's big one now. And when I say regular expression, this, okay. So it's basically trying to find out where all en has been found. Okay. And all right. No, I don't find the difference. Yeah. Okay. Now it does the same thing. The second one, greg. It's just that the first match it's finding and the two. Okay. So basically it gives a list of all the things instead of giving a vector. Reg expression gave us only the vector containing the indexes where it found. G Greg expression basically gives us a list of all the things. Okay, it's a list basically, not a vector. That's the only difference. Okay, what else? Because I don't see any other use case here. Because here you see it is 1, then 4, and then 2. En. Okay. 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 So 1, 2, 3, 4. So at fourth location it is found, and yeah, and then what else? Do you see any other difference? So in the first one it did not find anything. In second one it found, but at the fourth location. Then it did not find again anything. Then it did not find anything again, and so on. Okay, and after a while, okay, again it did not find. what else does it do? Here, 27th, it has found at fourth location. 27th, which is here, here, fourth location. Even at 25, it should have found, yes. So what else do you think it does? I don't find much of a difference between greg expression and reg expression. Right?
4 is found to
So let me just pick up
25th license.
So in a string, if there is a txt, right? The way we were defining it. If we had
25th one has some difference.
Okay.
License there.
So we have en, okay, and then we say things like this. Okay. So it found at fourth position here, and it found at fourth position, but did not find it twice here. Okay. It did not find it twice here. Okay. It only found once. Now, little too bigger number. So you can see that in this case, in the same string, it has found 4 or 6. Now you got the difference? I think this will make it more clear. All right. So I think this will make it more clear to you. So when we say normal search for this regular expression in this particular text, what it does is it basically finds this particular regular expression only once inside each element of this. That is why it gave us only one and then moved on. While when we say greg expression, it tries multiple matches everywhere. So it will first match at fourth, then sixth, fourth, and then sixth. While this one has been skipped by regex. Mitesh, Skylab, and Sridhar, Jagdish. Make sense to you? So that's the difference between regex and gregex. All right. Now, a string split we have already tried. It splits the string at each match to a regular expression. Okay. So if we have if we have a string split simply, let's say Sandeep, it will split it by character. Okay. If you put regex as very simple as empty, it will split it character wise. Okay, and after that you can basically access things in a single manner. Okay, now you can see that. So it returns a list of lists. Okay, so we first access that list using one. Okay, and then we can traverse over the list. So and so on. Okay. Everybody okay with the string split? And we could also say A, E, I, O, U. All right. Or anybody understands the difference between these two string split? Do you understand the difference between these two? First one resulted in 4 element because there were 2 E's, right? So if you split it by double E by E, it essentially will lead to two blank strings. Correct? So there was one string with a zero length,
between J and E.
E and E. Because there is double E, right? No? So what's happening is, I'm saying split my string Sandeep with vowel. Okay? So it is split A and D, then E and E. So blank string will come because it's splitting by single vowel.
There are two bytes.
What? This is the empty string. No?
Okay.
Not clear? Confusion, right?
But that is not everybody expects, right?
So if I say and here,
Okay.
makes sense now? Same thing, that's what I'm doing here. All right? Similarly, if you have got a data frame containing or a big list containing list of lists, it will further split it on those data sets. So for example, this one, if we have X, you can see X here. Okay. X is a kind of a data frame where first column is ASDF and something else and so on. Okay. So it's a vector, not data frame. It's basically a vector where first column is ASEF, second is QWERTY, third is YOP, fourth is B, and fifth is stuff. Okay, so X is that way. X basically is a vector, so no big deal. Whatever we have done so far, it will do the same thing. It has splitted that into these elements, each column. Make sense? All right. So everybody okay till now? We did a little bit of reshaping, aggregations. We also did string splits. We also discussed how to sort the data. So whatever we did with SQL, we are able to do using R as of now. Okay. In addition to SQL, we also showed you that you can do things like defining your own functions, doing SQL loops, which are not there in SQL, doing loops, and then cool things like even sorting the column names is something which is unique to data frames. So it requires a bit of thinking through how to manipulate your data using the basics. We also talked about joins today. So joins, aggregations, ordering, and shaping, reshaping the data, and all of those things we have discussed today. All right. Now let's talk about plot. So the basics of plot is is that R can produce graphics in many formats. It can create graphics on the screen. It can generate PDF file for LaTeX or emailing to the people. PNG or JPG bitmap formats for web pages, or on non-Windows platform to produce graphics for MS Office. Okay, so you can basically generate this. Whatever you generate here, I'll show you how to do that. And you can also generate the data for in PowerPoint and other formats. For printed graphics, you will get better results if you design the graph at the size it will end up. So generally, on Unix, you can simply launch the graphics like Windows and do this, and then it'll pop up in a next window, and afterwards we can start saving the data anywhere we want. Okay, so on Mac, you have to do just a second. On Mac, you have to do quads like this, and you can define. I can't see anything. All right. Now you can see quads height equals something. That's what we do. Let's try. Quads height equals 6 and width equals 10. Yeah. So it has opened in 6" by 7". Make sense? Now anything we draw will draw here. It'll draw here. Okay. Now also let me try to make a PDF out of it. Let's make a PDF out of it. How to make a PDF? I'll show you that. So I'm saying PDF my picture and whatever height we are saying here, and then after that we can draw anything. We can draw anything you remember. Plot x comma y. X equals to c minus 100 colon 100. Y equals to x into x, and we say plot x comma y, and then we say device dot off. What? Correct. So there are different formats, different ways. So if you are on Windows, you say window. If you want to save your data into PDF rather than showing on the window, then you say PDF. All right. Then you say PDF kind of things here. And then you draw the things, and the way we are drawing right now, we are saying PDF, picture.pdf. So it will store in my home directory with this name.
What is quad?
Quads is their window version in Mac. The way on Unix there is X11. On Windows it's normal Windows. So in Mac it's quads. Basically the Unix graphics on Mac is quad. Okay. Now it has saved the data in picture.pdf. You can see that. So it has created a PDF file that contains picture.pdf. Make sense to you? Correct? So what we did was, instead of saying show it on the UI, we started our window. In picture.pdf. So whatever we will do here will get saved into PDF right away. And then we can say device.off. All right. Good. Sounds cool to you? All right. Now these are few plot commands. You should pay a little bit attention to it. So if there are two numbers, then plotting plot will result in a scatter plot. If one of the factors, the first data type is a factor, then it will result in a box plot. Okay, in a box plot. If there are these two arguments where first one is a factor, second one is a factor, then if there are both the data type x and y, both are factor, then it will result in a stacked bar plot. All right. Also, there is a command called box plot There is a command called scatterplot, and there is a command called histogram to draw the histogram on the data. All right. In other way, you can write x and y instead of x comma y. You can also write the data like this. You can say wt tilde mpg, and you can say data is empty cars. So pick the data from empty cars, pick one column and another column and draw it. So would you like to draw it, please? Is it working for you? It's working. All right. So this way you can actually take a data set and present it. Now, and let me try the other ones also. Okay. So the important part is that here what we are saying is plot empty car dollar weight against empty car MPG. Okay. So now you can see that. Also from here itself, you can save it anywhere you want. Okay. Export to whatever you want to do. Now, if we had this thing as factor, then it will automatically switch to another. Basically, it switched to the what you call box plot. Okay, it switched to the box plot. I'll show you a better box plot this way. Okay, so yeah. So if you see as factor cylinder, if we say, it results in 3 values. Okay, box plot is always 3 values. Next is, if we want to do a stacked bar plot, we can do it using, so for each value, so we have got one label like this and another like this. So for each of the value like 4, what are the factors related to the gear? That's what is going to get plot. Okay. All right. So I'll show you in more details how to draw you know, these plots. Okay. Other very cool feature of R is the histogram. Okay. So let's say we can say histogram. Okay. We can say C 1, 2, 3, 5, and I'll plot it immediately. Okay. So the histogram, because histogram is very frequently needed. So if you say hist and say, this is my vector, what it will do is, it will do the frequency analysis quickly for you. It will find out, so 1 has occurred, so 1 to 2 has occurred how many times? Around, on an average, 3 times. 2 to 3 has occurred around 1 times, and so on. Okay, 3 to 4, 4 to 5, and so on. Make sense to you? Histogram does analysis quickly on your data and show you. So 0 to 2 has come 4 times. 0 to 2 means 1 plus 1, 1, 1, 4 times. Okay? 2 to 4 has come how many times? 2 times. which is 3 and 4. So this boundary is always inclusive to the left side, not to the right side. So which means greater than 2 and less than or equal to 4. Okay. So this boundary which we are talking here, so this one means 0 to 2, 0 is not included. This is 2 to 4 means greater than 2 and lesser than 4, and a total of that one. And then 4 to 6 means greater than 4, equal to or less than 6. Okay, that's what happens here. Similarly, here 10 to 12 means the value should be, now how much should be x-axis, y-axis, breaks. We can all customize all of these values. Okay, we can also define what should be the break size here. But by default, HIST gives you this wonderful way of representing data quickly. Okay, it's like immediate on numbers, it does immediate summary and displays it. Okay, similarly, if you have got words, this, or we say a string, a split. Okay, this is a great, this is another great. Okay, and we say string is split and we split it by space. So yeah, it wants the data to be numeric. I think that is the problem. It doesn't want my data to be. Okay, let me just try. Yeah, it wants the data to be numeric. You cannot plot the data just like that. Okay, so this one is working for everyone. So plot does a lot of things by itself. Okay. Now, you can use type equals to parameter to specify what kind of graph you want. If you are planning to draw lines, then you can put L. If you are planning to draw bars, you can put H. Or if you just want to do a scatter plot, then you can use this. Okay. So what does the first one mean? First one says plot ozone versus day where data is air quality. All right. Out of the air quality, pick up the column ozone, put it on x-axis. Put it on what axis? Yeah, put it on y-axis and put day on the x-axis and then plot the data. Okay, this is scatter plot. If we want to draw the line from previous to last one, we can draw that too. And this is how it will look like. It looks very, very awkward because the data might jump from one place to another. Okay. Similarly, if you want to just draw the bar, then you can use that. Now, sometimes it is good to add a line like this on the right hand side. Do you see a line here? If you want to do that kind of thing, you want to draw a dashed line or something as a measure of some other parameter. Okay, you can draw these things. It adds a single line on the plot. Okay, whether and you can define whenever you're drawing a line, you can always say whether you want solid, dashed, or dotted. There are many colors available, and so you can draw the line like that. Okay.
Can you
Yeah.
fit in line
What?
I want to draw the curve.
You want to draw the curve? Yeah, you can draw that. You can say a sin x, and then that will have the curve. But that one will be plot, not the bar line. All right. So AB line is for basically drawing a single line. Now, whenever you are drawing a plot, you would like to add more and more things to the more and more detailing to your plot. So first is with expression. It's just like attach function, okay, and just like attach function, and is good for a lot of things, okay. So when we say with cars means bring all the data set, all the columns outside. It's like attach. Now draw lines, okay. Draw lines of dist against speed. Okay. The x-axis is going to be speed and y-axis is going to be distance. And LOS is the curve fitting algorithm. Because when you are drawing straight lines, they will look very awkward. Here it will try to fit a particular line into a scatter plot. I'll show you, you will understand what does it actually mean. Okay. So let's just go step by step. Okay, let's just pick this one. Okay. So first we took the cars data, tried to draw. Okay, this is our data. Basically, that we have imported our cars data. It was anyway there. It was not really required. Okay. So we have plotted this awkward graph. You see, the scatter plot. This looks very awkward, and this looks very awkward because it doesn't make much sense. It's like scatter plot, no sense at all. Now we want to draw a line which is fitting the curve. See? See? So we have drawn a line which is going through the closest median of all of this data. Okay? This sometimes makes a lot of sense to us. When we do the statistical analysis, you will understand that why is this required. So you can see that with cars, we are able to draw the with cars data, we are able to draw the line. Okay. Okay. So attach cars. Attach. What was that? Cars. So this is what it is. Color. Let me just put some other color. I'm not sure what color. Yeah. Now it's blue color. It has just written. And line width is how big the line do you want? How thick line do you want? That you can define by LWD. Make sense? Okay. If the graph was the other way, then you would use this kind of technique. Never mind. So yeah. So this way we were able to plot the first one. First one is clear, right? With cars, lines is this and all that. Next is plot speed versus distance. Okay. And we can say that plot make the x and y both logarithmic. Sometimes what happens is when you observe that your data on x-axis and y-axis is so fast, when you are suspecting that your graph is not linear, your graph is more like exponential. What does it mean by exponential? When on the changes of x, your y is changing at very fast, or on the changes of x, y is moving extremely slow. In those cases, you try to change x-axis or y-axis into logarithmic. Okay. So let's say we are plotting this here. Now you can see on x-axis as well as y-axis. Let me just do first the x-axis. Okay, then that will make more sense to you. Okay, now you can see y on y-axis the data is linear, 5, 10, 15, 20, 25. Correct? So on y-axis the speed one is 5, 10, 15, 20 and 25. But on the x-axis 2 and 5, then suddenly 10, and then plus 20, then 50, and so its scale is logarithmic. What does it mean? If you take the logarithm of these values, okay, that will be the distance. Those distances will be equal. So can somebody tell me what is log of 50? You have r, right? You can say log of 50.
2.91.
How much?
Log of 50, right? 3.91.
3.9. So this here is 3.9. This is 3.9, and this 20.
2.99.
2.99. This is 3.9, right? Which is assume 4 and 2.93 and can you 2.3, right? So basically logarithm of these values will make it a linear, and that's why. So sometimes when the data on x-axis seems to be like running really fast, y is not responding at very large changes of x, or y is responding we are changing x at very fast, and graph is coming like really slow, going really slow. In those cases, you make the x-axis logarithmic, and then it will look a little linear. Okay, so let's say x is 100 and 100, and y equals to exp of x. So sorry. Okay, so you have x. Oh, what? This is correct only, right? Sorry, this is minus 100. So let me just draw it 0. So we have this. We say y. Now we have these many values. If you plot x and y, now you will see the values have suddenly increased. Or you plot y against x. Why it's so? Now it looks really awkward, right? Now if we say log equals to x, it is linear. Now you see the difference? So a graph of now if you see this here, take a look at this graph. What is this? It suddenly increased. It suddenly increased and then stopped responding. Okay. A better one would be if I take an example of say 10,000. Y is equal to this, and now see. So the graph is not really responding. You see, initially it increased suddenly for some value of x. It was like this, and then it became stagnant. Now the moment you say x, then it shows that it's linear. Okay, then it shows that it's linear. Make sense? So sometimes when a graph is really awkward and you're not able to figure out going really suddenly high, and you're not able to visualize, try putting one of the axes as logarithmic. Make sense? Now another smoother of the curve is lowest. The way we had, okay, we already explained lowest. There is, yeah, sub-SUME. Okay, there's another algorithm for curve fitting. It's little smoother for scatter plot. All right, so we can show you this also. All right, so this, the first line and second line, these two are the same thing. Okay, there is no difference at all. Now let's try to make it smoother with this. I'm trying to run with cars lines, same thing exactly, with a different color and different line width. Okay, so again, since I have spoiled all of my data, let me run whatever it was. So this is what we have right now. And now let me draw this particular one. And what does this do? It draws a purple line, a little better color, a little different curve fitting. You can see that we are trying to do another curve fitting on the same line, but in the using a different algorithm now. Okay. And also, you since this is not really greatly useful, it doesn't tell what is blue, what is tomato, and we need to put the labels on those. So you can put the legends. You can put the legends. So it shows that the what does we have just put a legend here. Okay. Okay. So these are the legends on the graph. So whenever you are plotting a graph, you can use the legend. Okay. So it has again drawn the legend twice. Okay. Next, I think this is good enough. Any questions on this? No questions? Sridhar, Skylab, and Jagdish. Mitesh has left, I think. All right. So if you try to draw it a little better way, okay, let me try to do a quads, and okay, so here I'll just take all of this and draw in a single shot. I think then it'll come out really better. You can see that. All right. So this graph looks good because of these putting the correct labels and all of this. Okay, doing the curve fitting. You see the difference between two curve fitting algorithms.
I think one is
here, the legend. You can see the legend. You can see the legend.
but actually the lowest seems to be more accurate.
No, actually here there are some data going out. Here, that there is some data going out and there is data going down. So it has tried to do more.
Above 4 are there, below 3 are there.
So super smoother is considered better than lowest.
So it is touching the points more closely. Yeah.
All right. The difference is very, very, very small. Okay. Now, so the box plot, you saw that the moment one entity becomes factor, it automatically converts your plot into box plot. But you can yourself define box plot. You can yourself call the box plot. Box plot is nothing but a box in which there are three values. One is left hand, right hand, and the middle hand. Okay. Box plot could be vertical or be horizontal. Okay. Formula meaning which axis against which axis we want to plot, and that what is our data, and what is I mean whether it's horizontal or vertical. Okay. Now you can see this. This is horizontal box plot. Okay. So a quick before even we will again discuss it when we talk about statistics. So here a box plot means the middle value is mean. Middle value is mean, and this each box represent 50% of the total data. Okay. And box plot could also mean left hand side, minimum and maximum, and this is my block. So and generally the box represents how is my data spread across. If the middle line is, this basically is shows that how is my data scattered. If middle line is too much towards right, which means most of my data is towards right. Okay. So box plots are good when we see the deviation, when we want to just see how is my population varying across median. Also, histogram we have already talked about. Bar plots are something like vertical bars where you have stacked or normal one, and okay. So inside this bar plots heights will be a vector. Okay, and what should be the names of each height? First height, second height, third height, fourth height. That will be dictated by second arguments called names.arg. Okay, and then you can have legend and other things. Okay. So histogram can work either on the variable. So histogram does multiple things. Other than plotting, it basically computes the frequency also, and then it does the other things. Okay. So it's already one. Do you want to leave or how?
Yeah.
Or you want to continue for half hour more?
Continue.
Okay. So you don't have to necessarily go, right? That's it.
No, if everybody goes there,
Okay. Maaf, thank you.
okay, we continue Monday.
So Jagdish, do you want to continue or should we stop now? Mitesh has left. Mitesh has some meeting.
Oh, then we'll.
Sridhar,
Everybody went there.
okay. So Skylab is saying he is planning to go. Jagdish is, I think. Jagdish, have you left? Are you there? So Jagdish, should we continue or should we break now? Because although there is a lot of stuff left, and
I have to leave.
okay, you can leave. Yeah. All right.
No, but only me and Jagdish will be there. All the other people will be going to that event.
Okay. Jagdish is saying till 1:30 will continue. Okay. Till 1:30 will continue. If you have to go.
I have to leave.
Okay. Okay. All right. You can catch up from the recording. Okay. Okay. Sridhar, then yeah. See you. All right. So these are the bars and histograms. This is how they will look like. And next is that we could create the graphics, the multivariate graphics, where import the full data set, and then uh, do many kind of plots onto the same axis. Okay, like this. On a single graph, we could draw multiple graphs. Okay. So let's say we import a library, data library called Lattice, and then we do xy plot on those two variables, and okay, and then plot it. Okay. So we'll do it one step at a time. There are multiple things involved. Okay. All right. So here, see that? Okay. So we can draw multiple graphs in a single shot like this. And what is it doing? Let's go step by step. So we are saying this library is clear, everybody? Then XYZ plot, ozone versus solar.r. What is this? We are talking about data called air quality. Okay. So what does air quality look like? Let's understand the data. Air quality. Okay. Or let's just say head of air quality. So it has one column called solar.r. All right. So we want to plot ozone against solar.r. Okay. And again, let's go to the text. So this is clear. Okay. Now here the formula definition is, okay, equal dot count temperature into 4 into equal dot count temperature. Okay. So basically 16 graph we want. Okay. So what are we doing here? We are saying, okay, let's just say attach. Okay. Now, so what we have done here is, by attaching data, we have made it available. Let's understand the output of this. Okay. So the output of this is, so temperature is this data. Okay. It has got these many points. And when we say equal dot count, as in, okay, so basically it converted the data into four equal ranges. Okay. So for this range from here to here, there are 61 elements. For this range from here to here, there are 67 elements. And for this range from here to here, there are 65 elements. This range here to here, there are 68 elements.
But the ranges are overlapping.
Correct. Overlap between adjacent intervals is 32, 35, and 41. Okay. So what does equal dot count do? Equal dot count. Functions to handle shingles. Okay, equal dot count. Okay, so what does equal dot count do? It basically
There is an equal count algorithm. Equal dot count converts X to singles. Single is like a factor with overlapping levels.
yes. So shingles is like factors with overlapping. So what we are doing? Say temperature is there, right? So if we say single and temperature, okay. So it basically has converted it into, okay, one has occurred 56 times and so on. So basically it is converting our temperature into four set of intervals, four intervals, 1, 2, 3, 4, such that the the counts in the four intervals is almost equal and they are overlapping intervals. The question is, why do we need the overlapping intervals? All right. Never mind. Okay, so actually this should be after the statistics.
No, yeah, fine. I think in that plot now we can give factor also as well.
Yeah. So the idea here was, I think this is little stepping ahead. Okay. So the idea here is to basically display many charts in a single shot. So plot one plots the two main variable x and y and divide the remaining two on 4 by 4 basis by dividing them uniformly in four groups depending on their value. Okay. So we are dividing the temperature data into four equal groups, almost equal groups, and then trying to plot them 4 by 4 groups, and then trying to plot them. So one data is temperature data, other is wind data, and we have divided into four, which means there are total number of 16 groups. Okay, the total number of 16 groups, and once you have defined this, we can basically display it. Okay, so you can see that. So here, how many groups are there? There are more than that, actually. Okay. Here, online. So you can see that basically each is 10, not more than this. let's just plot the first one first. Okay, let's just plot the first one first. All right. So basically, total data has been divided into 4 groups. Okay, and then we are trying to draw the 4 groups separately. Okay, never mind. I think we should cover this later again. We will cover these multivariate graphics. We'll cover it again. All right. Where is the comments window? All right. All right. So apart from multivariate graph, where we are trying to do multiple graphs, I think we should just take a better example, a simpler one, and then we try to explain it. Okay. We'll do that maybe later. Okay. And now let's talk about data analytics with R, the second day. And today we are going to discuss more about statistics, the second day. All right. So every now and then, how many times do you not hear a lot about these anecdotal incidents, right? That even though my uncle smokes so many cigarettes a day, he's doing great. While these anecdotal incidents do not make any sense. Why? Because let the data speak. And let the data speak methodically rather than just taking few instances and then talk about it. Okay. The other reasoning is that it, basically, if you look at people's stories, you may end up believing something which is totally wrong. Okay, there has to be a date. There has to be a statistical support to any of the conclusions driven by people. It should not be just based on hypotheses or based on few stories. Okay, and that's where the statistics comes into play. Statistics makes it possible to logically analyze the data and represent it. Okay, so the way when we do let's take a case of even the smoking case. Okay, early smoking research, when there was no formal studies done and formal analysis done, there were stories, there were anecdotal incidents. And then after a study, the reaching to a conclusion like smoking is a complex human behavior, by its nature, difficult to study, confounded by human variability. Now, this is some other statement by cigarette company. But to actually analyze it properly, you have to first form a research question, that what exactly we are talking about. So let's say the research question is, are consumers of certain alcohol brand more likely to end up in emergency room with injuries? Let's say this is the research question. Or research question is, are people who are smoking 5 cigarettes a day more prone to cancer as opposed to people who are smoking 0 cigarettes a day? So that is your research question. Then comes your population. Who does my question apply to? Okay. Okay. Is it only applicable to American, Russian, or Chinese? Who is my target audience for my research question? Third is the sample. Now, fine, we are happy that we have picked up this kind of a research question for that kind of population. What is the sample available to us? Okay. So if sample available is very localized, then our population, the research question and the population it applies to will have to be changed. Okay. I mean, to what it generalizes to? It does not generalizes to everyone. It will generalize to only a smaller geography. Okay. So when we do the data analysis, the first and foremost thing comes is the variables. Variable can either be numerical or it could be categorical. Numerical as in 1, 2, 2.5, 3, 3.5. Categorical is good, very good, not good, and that. Okay. Categorical could also be red, blue, black. In numerical, you have continuous and discrete. Continuous as in you have the data like 3.5, 3.51, which is decimal number. Discrete is 1, 3, 5, 10, and so on. Categorical also has two kind of things. One is regular, as in red, blue, black, or maybe categorical could be poor and rich. Ordinal could be there is an inherent ordering in the data, like good, very good, poor, excellent. So that is ordinal. There is a labeling. In our factors, factors are meant for the categorical data, while our numeric data is for numerical data. All right. Now this is a typical data set. Country wise, we have country and then we have observations. Okay. This data is essentially a data from all the countries across the globe. Which country is asking Google? Which country is asking Google how many of requests, how many of data? Okay. So for example, the total requests raised by Argentina to Google is 21, and Google complied with 100% of data. Then then user data requests were 134, and then okay, this is another request. Now, which hemisphere does Argentina lie, southern or northern? And then HDI, some other factor is very high, very low. So HDI is your ordinal categorical, hemisphere is your regular categorical data, and CR complies continuous numerical because all the values are covered, because these are percentage data. Percentage data is continuous. CR request is discrete and numeric. Continuous this continuous data means from 0 to 100, all the data will be covered in this range. All right. So that's our normal kinds of data. All right. In a random process, we know that outcome could happen, but we do not know which particular outcome will happen. Okay, Jagdish. All right. See you then. Have a good day. All right. So I think we should break. All right. Thank you. See you on Monday at the same time.